Automatic, Addison.
In this tutorial, we will create a Python publisher for ROS2. Knowing how to write a publisher node is one of the most important skills in robotic software engineering. In ROS2, a Python publisher is a script written in Python that sends messages across the ROS network to other parts of the system. On a real robot, you'll write many different publishers that publish data that get shared by the different components of a robot. Strings, LiDAR scan readings, ultrasonic sensor readings, camera frames, 3D point cloud data, integers, floats, battery voltage readings, odometry data, and much, much more. Before we write our first publisher node, let's understand some ROS2 vocabulary. In a complex robot, you're going to have many pieces of code in your system that need to communicate with each other. For example, the code that is responsible for making navigation decisions needs to subscribe to laser scan messages from the LiDAR to be able to avoid obstacles properly. You might have another piece of code that reads from the battery and publishes the percentage battery remaining. In ROS2, the parts of your system that are responsible for publishing messages to the rest of the robot, like the distance to an obstacle, are known as publisher nodes. These nodes are usually written in C++ and Python. You have many different types of built-in messages that you can publish over ROS2. For example, if you want to send distance information from a LiDAR sensor, you have a special sensor message called laser scan. For battery health, you even have a special sensor message type for that called battery state. You've got many different message types. And in a previous tutorial, we published the text message hello world from a publisher node called talker. This message type is a string, which is one of the standard message types in ROS2. You've got other standard message types for integers, floating point numbers, Booleans like true and false, and many more. And that's the beauty of ROS2. There is a message type for 95% of robotic scenarios. For the other 5%, you can create your own custom message type. I will show you how to do that in a future tutorial. The parts of your system that subscribe to messages sent from publishers are known as subscriber nodes. Subscriber nodes are pieces of code, usually written in C++ or Python, that are responsible for receiving information. For example, the robot's path planning code could be a subscriber node since it subscribes to LiDAR data to plan a collision-free path from an initial location to a goal location. Messages are the data packets that the publisher nodes send out. They can include information like LiDAR scan data, camera images, ultrasonic sensor readings, numbers, text, or even complex data structures. You can find a master list of the different types of messages by going here to the ROS2 documentation. You even have other message types to represent things like bounding boxes for object detection. Topics are the name channels over which messages are sent out. For example, in many real-world mobile robotics applications where you're using LiDAR, messages about the distance to obstacles are sent on a topic named scan. By convention, the name of a topic in ROS2 has a leading / before the name. Topics allow different parts of a robot, or rather different nodes in a robotic system, to communicate with each other by subscribing to and publishing messages on these named channels. Okay, now that we've covered some fundamental terminology, let's write some code. Just going to go to the root right here, and let's go into our package that we created in the last tutorial. So I'm going to do ~/ROS2 src. Okay, and I'm here. I'm going to clear that. And now let's open Visual Studio Code, code space, period. Okay, and now let's X that out. You can see our package here. Now let's create a new folder in here. I'm going to right click on ROS2 Fundamentals Examples. I'm going to click New Folder, And let's create a new folder that has the same name as the package name. So in this case, it's going to be ROS2 Fundamentals Examples. Okay, and now we have our new folder here called ROS2 Fundamentals Examples. Pay careful attention to the name of the folder, okay, because this is where we're going to house our Python scripts. The name of this folder must have the same name as the package. So let's right-click on this package, click New File, and let's create a script called py-minimalpublisher.py. So I'm going to type here py-minimalpublisher.py. Here's our Python script. And we're going to create a ROS2 node that periodically publishes hello world messages on a topic. And this is going to demonstrate basic ROS2 concepts such as node creation, publishing, and timer usage. All right, so let's start out here. We're going to go through every step here. In future lessons, I'm just going to show you the code and then we'll walk through the code. But in this one, let's go through line by line every step here. So here I'm going to do /usr/bin, bin, /env, Python 3. Okay. And that line, that first line is called shebang. Shebang. You might have heard of it. And this line is very, very common in Python programs. So let's go through this piece by piece. So this !, that's the shebang itself. So it tells the operating system, use the following interpreter to run this script, okay? This user bin env, this piece right here, runs the env command, which is a Unix utility used to find and run the appropriate version of the specified program, in this case, Python 3. So this right here, this piece, Python 3, tells env to look through your system's path to find the Python 3 executable. So by doing this, it's very, very good because on different systems, Python 3 might be in different locations. It might be in user bin Python 3 or user local bin Python 3. So by having this env right here, it ensures that the first Python 3 in your path on your system is used. So it's very, very helpful in development environments. So that's the shebang line. You'll see that a lot in programs. Okay, now let's write some comments. Let's write a header right here that's going to describe our file. It's our doc string. Okay, and I'm going to say description. I want to bring this over. Okay, bring it all the way over. And let's give our code a description. Okay, and let's say this ROS2 node periodically publishes hello world messages to a topic. Okay, very basic here. Okay, and now let's do a separator here. And I like to do this in my script. I like to, at the top, make it very clear to whoever looks at this code in the future, it's clear what topics this script is publishing to and what topics for ROS2 this node or this script is subscribing to. It makes it very, very easy for people who come after to understand. So publishing topics. So we're going to say this, the channel containing the hello world messages. Okay, and they're going to pi. Name of the topic is going to be pi example topic. And the message type is going to be a string message. And that's stood messages string. So if I go in here, I'm going to go to Google. And you can see stood messages string ROS2. So we can understand this message type. And you can see that this is the definition of the string message. And it just has one field, which is the data, which is the actual string that you would like to use. Okay, string message. You can see it's been pretty much the same all the way back to older versions of ROS, even ROS 1 and Lunar. It's way, way, way back when. It's always been fairly much the same definition. So this is our string message type. So now let's add subscription topics. Subscription topics. Okay, and we're going to have none in this code. And let's add author. Addison, Sears, Collins. And date. Today is April 4th, 2025. Okay, so that's our header. Very nice, clear header that tells what the code does in the description, what our topics for publishing are, what our subscribers are, and then our author and the date. Now let's do our imports, import our libraries. So we're going to import RCLPY. Let's add a little comment. I'm going to say import the ROS2 client library for Python. Let's do from rclpy.node, import node, pound, I'm going to say import the node class used for creating nodes. Okay, and then the next one is to be able to publish a string, we need to import it as a library here so we can be able to use it, the string message type. So we're going to say from stood messages.msg import string. And this will enable us to use the ROS2 string message type. So import string message type for ROS2. Okay, and now you're going to create your first publisher node. And to define that, we do that by creating a class. So class, and I'm going to call it minimal pi publisher and then node. Okay, and let's add a comment here. Our summary is going to be create a minimal publisher node. No arguments here. Let's just get rid of that piece. Okay, and now we need to define our class. So I'm going to do def init self. Add our comment again. Create a custom node class for publishing messages. Okay, go to the next line. Now we need to initialize the node with a name. So I'm going to do pound initialize the node with a name. Okay, and to do that, we do the super dot init underscore open parentheses minimal underscore pi publisher. Remember that syntax. So that initializes the node with the name. We use the super dot init and the minimal pi publisher. Minimal pi publisher is the name of the node. Now let's create a publisher on the topic. Okay, with a queue size of 10 messages. Okay, a queue size of 10 messages. And let's create a first one. We'll do self.publisher1 equals self.create. So to create publisher, we call the create publisher method, which is a member of the node class. And we're going to publish a string message. So the first field in here in the create publisher is the message type. The second field is going to be the topic name to which you want to publish. I'm going to call it /pi underscore example topic, comma 10. Save. That's the queue. The queue size is 10. How many messages are in the queue? So if you got a lot published, you're publishing at a high frequency, 10 will get held up in the queue. All right, and let's create a timer to dictate how often we're going to be publishing the message. Let's publish it every half a second. So create a timer with a period of 0.5 seconds. Okay, to trigger publishing of message. Okay, and we do self.timer equals self.create timer period, comma self. Okay, self dot timer callback. Okay. Okay, and let's define timer period to be half a second. Okay, so every half second, we're going to call this timer callback function. We haven't defined this timer callback function yet. We will do that in us next steps here. And let's just create a counter variable. This is not required, but I think it's interesting for our use case right here. So I'm going to say initialize a counter variable for message content. This will show the label, the message. So like it'll count up the number of messages. So the first message will be 1, the next one will be 2, the next one will be 3. So we'll count up like that. And we'll initialize it at 0. Okay, now what is our function, our timer callback? What's the function that we want to run every half second? Okay, and in this timer callback is where we're actually going to do our publishing, and we want to publish every half second. So we need to define a method called def timer callback self. And I'm going to say callback function executed periodically. Okay, by the timer. Periodically meaning every half second. And let's create a new string message object. So MSG is equal to string. This prepares. Okay, this prepares us for when we want to actually publish our string. So we create an empty string message, and store that into the MSG variable. Let's set the message data with a counter. Okay, so remember when I showed you over here, let's go Google again, say stood messages string. You pull that up and our field right here is data. The name of it's data. So that's what we need to fill in. We created a blank string message and we need to fill in the data field of the string message. So that's what we're doing here. We created a blank string message. We stored in the variable MSG. So we do MSG is equal to, MSG dot data, which is the name of the field. And we need to fill it in with a value. So I'm going to do hello world and then our counter. So we can count out, keep track of how many messages we've sent. So %self.i, there's our counter. Okay. So it's going to say hello world 1 and then 2 and then 3 and then 4 and then all the way up. Because self.i is what we initialized. That's a counter variable to 0, and that's going to be used. That's going to be replaced into here, that %d. So now let's do self.publisher1. Okay, remember we had our publisher right here. We created it here and stored it in the self.publisher1, but we now created the message, but we need to publish it. So let's do a comment here so you understand what's going on. Publish the message you created above to a topic. Okay. So we do publish and MSG. So it's very good to start with strings. This is the most basic publishing we can have before you dive into doing exotic publishers for robotics, publishing ROS to LiDAR data, publishing ultrasonic sensor readings. String is a very good example to start with because you just get a basic understanding of the architecture of what a publisher looks like in actual code. So here we have, again, define the message, empty message. We filled the data field, hello world, right there. All right. Okay, and then we have this right here, which is the actual publisher publishing the message we had above. And let's create a log message. Log a message indicating the message has been published. Okay, and to do logging, you do you call the get logger method .info, and we'll say publishing %s, and then %, and then msg.data. Okay. So we're going to say publishing and then the actual payload right there, which is the actual message. And then to finish this method, we need to actually increment the value of the counter by 1. So it's ready for the next message. Self.i plus 1. Save. Looking good. Okay, so there it is. There's our publisher. We defined it right here in this init method. All the variables constructed it. Okay, and then we have our timer callback, which is a function that runs at the timer period, so which is every half second. So every half second we're going through here and we're doing this publishing right here. All right. And so now let's do def main args equals none. Create our main method here, which will start this ROS2 node upon launch. Okay, and I'm going to say main function to start the ROS2 node. So we have args and then list, optional. Okay, and then here, these args, we're just going to fill this in, not very important. So I'm just going to say command line arguments. This is if you want to run the node in the command line and then add arguments on the command line when you run it. But this is going to default to none. You don't need to worry about this. Don't worry. It's extra. Okay, but this is important, this piece in the main function. The first thing you're going to do in the main function is you need to initialize ROS2 communication. And to do that, we're going to do RCLPY, which is a ROS2 Python library. And to initialize, we do init args equal args. Now let's create an instance of the minimal publisher node. Okay, and they're going to call it minimal py publisher. And let's create an instance, minimal publisher. We'll use our class we created right there. Okay, and that little squiggle is because we haven't yet used that variable, but that's going to go away in a second. So we need to keep the node running and processing the events. We need to keep it running and keep calling that timer callback so we can keep publishing hello world. Let's do that now. And to do that, we do RCLPY, and we use the spin method, SPIN. And what are we going to spin? The node, minimal py publisher. And then when we're done, we need to destroy the node. So destroy the node explicitly. When we're done, we press Control-C to close the program on the terminal. We need to kill it. So we do explicitly. Okay. This is optional, but I like to add this. So we're going to do minimal py publisher dot destroy node. Destroy dot node. Oop. Destroy node. There we go. Okay, and then finally, you want to have it cleaned up. So we do shut down ROS2 communication. RCLPY.shutdown. This makes sure all the resources are cleaned up after we close down the node. So let's finish this out. If name is main, okay, we do, so what we're doing here, we're going to execute the main function, which is the function we defined above, the main function, if the script is run directly. So if we just run this script, you want to run, like just alone in the terminal, we want the main function to execute. So the other alternative is if we were to import this into another piece of code and then we run that code in the terminal, this main function would actually no longer apply because we're actually importing it more as a library utility into another function. But in this case, we're running this node outright directly. So we do want the main function, this right here, to actually execute. So we do main here. That's what this means. You'll see that commonly. And let's save. And let's see why this is screaming. Invalid syntax. Let's see why. If main. Oh. Save that. Okay. Needed a space between the F and the underscore right there. That's why I was screaming. Everything looking good so far. Okay. So here's what we got. You can see we have the detailed comments in here, and everything is we're just going through. So on a high level, what we're doing in this node is we're publishing a string, okay, called hello world, to a topic named Pi example topic. And the string message will also contain a counter that keeps track of how many times the message has been published. So that's this counter right here. We chose the name Pi example topic for the topic, but you could have chosen any name. Okay, so now we've created our node. Okay, so now we need to configure our package so that ROS2 can discover this Python node we just created. To do that, we need to create a special initialization file. Right-click on the name of the folder right here. Click New File. Okay, and let's call this _12, and then init _ again, .py. And then enter. Okay, and let's at the top, let's say pound and required to import Python modules. This file is required to import Python modules. And having this init.py in this particular folder, which is the same name as the package name, what it does is it designates the directory as a Python package. So it enables Python's import machinery to recognize and treat it as a cohesive collection of Python code. So all you need to do is just save, Control-S, and close. That's it. Now let's create a README.md file. A README.md file is a plain text file that serves as an introduction and explanation for a project, software, or package. It's like a welcome mat for anyone encountering your work, providing essential information and guidance to get them started. So let's right-click over here, anywhere here. We're inside our package, and let's create it. README. README.md. And I'm going to take the caps away on that. Okay. So to see what the README.md file looks like, you can right-click on the README.md and click Open Preview, and that'll show you what it looks like. But we have nothing in there now. So let's write some stuff in there. First, we're going to, before I do that, let me show you a website. Let's go to Firefox. Okay, and let's go to Google and getting started writing README GitHub should be the first. Yeah. So this website right here, what I typed into Google, I typed getting started writing README GitHub. And this right here, you can use this website right here, it'd be the first search result, to show you the syntax for creating a README.md file. You can see that here. I won't go through the whole thing, but it shows you step by step how to create a README.md. Let's create a basic one from scratch. So I'm going to do pound. Let's put the title, ROS2 fundamentals examples. And let's say this package contains examples demonstrating fundamental ROS2 concepts. Okay, and then under here, we're going to do a description. We do the 2 pounds in the description. So let's say this package includes minimalist ROS2 code to demonstrate important ROS2 concepts and patterns. Okay, And just a little note here, following ROS 2 Python style guidelines. Now let's do some prerequisites. Prerequisites. It's requirements you need for this package. So we need to have ROS 2 installed. We need to have Python 3. And we need to create a ROS 2 workspace. And we're going to call that, it's called ROS 2 workspace. Okay. And let's do author, Addison, Sears, Collins. All right. And let's save. How we looking? How we looking? How we looking? Okay. By the way, these symbols right here, this little symbol, it's on the upper left of my keyboard if you're using a US keyboard, little accent right there. So this is our basic README. All right, we save. Let's right click on it, do open preview, and you can see what it looks like right here. Pretty cool, huh? Nice preview of how our README file looks like, looking very professional. That's our README.md file. Now let's open the package.xml file. So the package.xml file is an important part of any ROS 2 package. Think of package.xml as your package's identification card. It's like the ID card for the ROS 2 package. Just like how your ID card contains essential information about you, your name, date of birth, ID number, and address, the package.xml holds key details about your package. So let's take a look at that now. Pop it open. Let's close the README.md and let's fill it in. So we've got let's click that out. Package name, version, let's keep it 0. Let's give it a description. Let's say basic examples demonstrating ROS 2 concepts. Okay, and instead of this to do, I'm just going to say automatic Addison at example.com. And let's put my name here since I'm the maintainer. Okay, I meant CMake. Let's add in another one called CMake Python, which we'll need to build Python scripts. So CMake _ Python because we've got Python scripts in here. And let's add in some dependencies. So these dependencies come from the script we just created earlier. I'm going to add the RCLPY library. So depend RCLPY. And these dependencies will be pretty standard for any packages where you're having Python nodes. Let's add another one to handle C++ nodes as well. So I'm going to do depend. And let's do RCLCPP. So our package will be able to handle both C++ code and Python code. And for that, we need the C++ library for ROS 2 and the Python library for ROS 2. And then we also have the standard message type library, which we use because we're publishing the hello world string. So I'm going to do std messages. And let's save. Looking good, looking good. So breaking down the key elements, we have the name, the unique identifier for the package, often corresponding to the folder name. The version, what version are we using of this package? In this case, this is the absolute first version, so I'm going to do 0. Description is where you put a brief explanation of the package's purpose and functionality. Maintainer, this is who's maintaining the package. It's me. License, I'm using Apache 2.0. This specifies a license under which the package is distributed, so it indicates how others are permitted to use, modify, and redistribute the package's code and other assets. And you can Google Apache 2.0 to learn more about that. And below here, we've got our dependencies. So we start off with the build tool dependencies. Build tools, like compilers, are needed for building the code in the package. All right, and we need immense CMake for C++ and immense CMake Python for Python. Now we've got depend right here. All right, and these package dependencies are those that are required for building the package. And again, as I said, since we're publishing the std message type, we need to make sure that library is in our dependencies for this package. All right. Now we have our test depend, and these are tools used for checking code for bugs and errors. And then at the bottom here, we've got our build configuration piece. Export defines properties and settings used during package installation. And then build type specifies the build system. In this case, we're using immense CMake. Now let's configure the CMakeLists.txt file. A CMakeList.txt file in ROS2 defines how a ROS2 package should be built. Let's open it up. I got all this gobbledygook here. All right, we're going to break it down later. So this file right here is very important. You'll find it in every ROS2 package, and it contains instructions for building and linking the package's executables, libraries, and other files. All right. So you've got, this is the stock standard one that gets built immediately when you create the package. And right here, let's start here. This is where I typically start, where we add our dependencies. Let's create some placeholders here, and let's go through. So first thing we need, immense CMake Python, just like we had in our package.xml. So you're probably wondering, why do we do this again for both CMake lists and package.xml? Well, package.xml is, again, it's like the ID card. It provides guidance to show what dependencies, what packages the particular package depends on. So we can actually run a command, and that command will search the package.xml and automatically install any dependencies it finds in the package.xml. Whereas CMakeList.txt is actually used by the ROS2 system for building the code into executables so that they can be executed when you want to run them, when you want to run the nodes. So they serve two different purposes. So you need to put the dependencies in both places. So let's go here. We're going to do RCL CPP. Let's go down here. Let's get RCL CPY. RCLPY for the Python library. And then we need our std messages. Let's get rid of that. And that's all we need for now. Now let's define a variable named dependencies that will store the dependencies of this particular package. Okay, so it'll list all the packages that other dependencies that the project requires. So all the packages and dependencies that the project requires to actually run. And so we're going to set a variable for that. So I'm going to do set dependencies. Otherwise, with each executable we create here, we'd have to list out all the different dependencies above here, one by one for each one. But we're going to store those in a variable to make our code, our CMakeList.txt, much cleaner. So let's go dependencies. Nope. Let's go set dependencies. Okay. Let's get rid of that so you can see that. Let's go RCL CPP. And then let's do std messages. Save. Okay. Okay, now I'm going to add specified directories to the list of paths that the compiler uses to search for header files. So this is important for C++ projects where you have custom header files that are not located in the standard system include paths. So let's do that now. I'm going to go include directories. It's already there. And it's going to be include, which we have up here in the upper left. Okay, now continuing on. Now what we need to do is to tell CMake to create an executable target, okay? And this is going to be a placeholder, which we're going to use much later for our C++ files. When we create a C++ publisher, we're going to need to actually write these lines of code. But I'm already going to add the placeholders, and we'll just comment it out for now. So let's do that now. We're going to do add executable. I'm going to do minimal CPP publisher source folder src, which is in the upper left. That's where we're going to put in the future our C++ publisher once we create it. So I'm going to go to minimal CPP publisher.cpp. Save. Let's go down below here. Pound, amint, target, dependencies. Don't worry, you'll do this. You can see many examples of this in many ROS2 packages. You also see in the official ROS tutorials. So you're going to need these two lines when you write C++ code. One to add the executable, and then one to add the dependencies for the executable. And remember, we added our dependencies here as a variable. So all we have to do in this case, so say we have a publisher, C++, called minimal CPP publisher.cpp, which we will write later. It's going to be in the source folder. You add that line, and then in the next line, you need to tell the compiler what the dependencies are. So minimal CPP publisher, which is the name of the node, and then we're going to do $, and then we're going to do curly braces and dependencies. Let's make sure I close those curly braces. Okay, good. So that's our C++ publisher. Okay, and let's copy again, because later we're going to actually do a subscriber. So let's just change publisher here to subscriber. Okay. So now we've got that now. Now we need to create a designated location, okay, in the project where we're going to copy necessary files. Okay, so we do install here, okay, and then directory, and they go ROS2 fundamentals examples, and destination, okay, and then share. Okay, and then this is going to be where the actual, so we have our development files, which are in the regular area here, and these are going to be the files used for the actual build. So project_name. Okay, so that did that. Now let's do this, install. Okay, and let's see, directory, include, Okay, destination. Is that spelled correctly? Destination, yep. Okay, and we're going to do share. Sorry, been a long day. Include. Okay, so this handles the actual code in the package. And then we have a special area for our includes, for our header files. All right, and it's continuing on. Now we will need to have install the C++ executables, okay? And that's going to be in a special folder called lib. So let's do pound install CPP executables. Don't worry if all of this doesn't make sense, by the way, right now. It will eventually when you have more practice with this, creating more nodes. You're going to do this again and again and again. So no need to memorize anything. Just follow along at home. So install and then targets. Okay, and this is where we're going to declare our executables, minimal. I'm just going to go up here, copy, and put that here, and then copy and put this here. Okay, and then under here, destination, lib, project underscore name. Okay, now we need to install Python modules for importing. Okay, and the Python modules are going to be in the same name as the project name, which you saw earlier. Okay, it's going to be in here, this ROS2 fundamental examples. Again, all of this may look like hieroglyphics now. Don't panic. It was for me when I was first learning ROS2. All this will make sense the more you get hands-on experience with ROS2. Just follow along, and your muscle memory will start to grow. So we're going to do install Python modules for import. These are modules, libraries, same thing. Install Python libraries for import. And we're going to do a mint Python install package. $, project name. Let's go down here. Okay, and now let's add this. Now this is the part where, so up here, just to high level, this is where we handled C++ code that's in our package. Now we're working on our area with our Python scripts, which is the only script we've written, which is the Python publisher. So this is where we are going to add the section to install Python scripts. So add this section to install Python scripts. All right, and so far all we've got is a Python publisher. So we're going to go to install, which is the directive for the compiler. We do programs. ROS2 fundamentals examples, py underscore minimal publisher dot py. Publisher dot py. Okay. ROS2 fundamentals examples, py minimal publisher dot py. Looking good. And let's do destination. Lib, $, open curly braces, project name. Okay, save it. All right. Looking good, looking good. You don't need to touch this section right here. What this does is it automates the process of setting up linting for the package, which is a process of running tools that analyze the code for, errors and style issues and other discrepancies that don't adhere to specific best practices and coding standards. But you don't need to do anything here. But we will do here, we're going to add one additional line, which is going to be used to export include directories of a package so that can be easily included by other packages that depend on this package. So to do that, we do int export include directories include and save. All good, all good, all good. So let's walk through this CMakeLists.txt. This is very fundamental. So on the first line right here, you're specifying the minimum required version of CMake for building the package. This is typically set to a version that is known to be compatible with ROS2, with your ROS2 version. This project line right here specifies the name of the ROS2 package. Here, we're saying find and load the necessary dependencies for this ROS2 package. So here's where you'll list all the dependencies for your scripts in your ROS2 package. Set dependencies right here lists all the packages and libraries needed by the project. Include directories right here tells the compiler where to find header files for your C++ code. Okay? Include directories. Where to find the header files for your C++ code. We're not using this yet because we're just running a Python script. The add executable right here, these two lines right there, they create an executable program using the specified source file. We will add the publisher and the subscriber in a future tutorials. The submit target dependencies line right here, it has a syntax where you have the program name, okay, the name of the node, and then the dependencies. It links the program with the required dependencies. So now down to install directory destination. This copies the folders to the project's installed directory, okay, for sharing, all right, for use in the build. So we're not toying around with the development files there. Then we have this line, lines 39 through 42, where we install the header files to the project's install directory. Moving along, we have all of this gobbledygook, which is now commented out. What this does is it installs the built C++ programs to the project's install directory. We'll use these programs later. And we have this line, which is install Python modules for import. Okay. And then we have, here is where we install our Python script. And then down here sets up the code checking, linting, if testing is enabled. And then down here, this allows other packages, this is a package, ROS2 fundamental examples, but maybe we have got other packages that want to use header files from this particular package. This line enables other packages to do that. And then this last line generates necessary files for other packages to find and use this package. So this is the architecture of your basic bare bones CMakeLists.txt file. It includes capabilities for both C++ and Python code. You will use this and look at this again and again and again repeatedly over the course of your ROS2 career, along with the other file which we created previously, which is the package.xml. Both are very important. So now that we have created our script and configured our build files, we need to build everything into executables so that we can run our code. And to do that, we need to open a terminal window, move to the workspace, cd ROS2, okay, and then type build. And it looks like we've got an issue in our CMakeLists on line 11. So let's go check it out. Line 11. Oh, got an error here. Parentheses that should not be there. So let's save it. It's clear. And build again. Okay, and we've got a problem on 56. What's going on 56? What's going on 56? Install. Okay, programs, ROS2 fundamentals, examples, py minimal publisher.py, destination, lib. Oh, let's get rid of that space there. Let's try it again. There we go. Okay. See, it's very sensitive. Okay. I use the build command to build. Now, what does the build alias do? So let's do get it bash rc, and so you can see what the build alias does. I created an alias. All it does is it goes to the workspace, cd workspace, and then it runs :build. Okay. So that's what it does. I've got another build alias here that moves to the workspace, build it, and sources the bash. Actually, that's the one we need to use. So let's comment this out. Okay, and let's run build again, because after we actually build, we want to source the bash rc so that everything refreshes and it recognizes the new build file. So let's go here, let's clear, let's build. There we go. All good. We could have also done this, which is the same thing. cd ROS2, okay, :build, and then source bash rc. Same thing, but I like to make my life easier. Now it's time to run our node. All right. So what we need to do to run the node is you're going to do ROS2 run, then the package name, ROS2 fundamentals, examples, and then the name of the node. What's the name of the node again? I'm now having a blank, drawing a blank. It is py minimal publisher.py. That's right. Okay, so let's do py minimal publisher.py. So that's the syntax. We do ROS2 run, the name of the package, and then the name of the script. Okay. So before we do that, you could have also done this: ROS2 run, ROS2 underscore F, and just press the tab button. It'll autocomplete. And then you can just type P and then press the tab again. It'll also autocomplete. So now press enter. And here's what your output should look like. You can see we are publishing. Pretty cool. Pretty cool, pretty cool. And we're doing it every half second. Every half second, you can see that in the timestamps there. This is the Unix timestamp. The time since January 1st, 1970. All right, in seconds. All right. So now let's open up a new terminal window. Let's let that run for a second. And let's look at all the currently active topics. And we'll do this command, which you are going to use all the time during your ROS2 career. It's called ROS2 topic list. This lists the topics. And here we can see our topic, py example topic. All right, and if we X out of that and we go back to our node, you can see that matches the topic name that we had here, Pi example topic. So Pi example topic. Okay, and let's do ROS2 topic. Before I do that, let's just explain these others. Probably wondering, what is parameter events and what is ROS out? Well, parameter events and ROS out, these topics appear even when no nodes are actively running, okay? This is due to the presence of system-level components in the underlying architecture of the ROS2 middleware. The parameter events topic facilitates communication about parameter changes. You'll learn about that in future tutorials. Okay, and then the ROS out right there, that topic provides a centralized way to access log messages generated by different nodes within the ROS2 network. You can ignore both of these topics. We only care about this one, the one to which we're publishing Hello World. Let's see what's coming across that topic. And to do that in ROS, you do ROS2 topic echo, okay, and then the topic name. Remember that. ROS2 topic list lists all the active topics. ROS2 topic echo shows you the contents of a particular topic. So we type the topic name, type Pi, and just press the tab button. And you can see here the data that's coming out is a string, this data field. Remember that from an earlier tutorial that we went here, we did this, go to stood messages string. See the data field, it only has one field, this type of message, the string message called data, and it's of type string. That's what we have here, data, and then we have our string, hello world, just like we had in our code right here. ROS2 topic list, ROS2 echo, very important commands. Remember them. Now let's Control C to close that out. Now let's do ROS2 topic hertz, Pi example topic, and hertz. That's the number of something per second. So it's the number of times we're publishing per second. All right, that's the frequency. So let's see the frequency right here. And we can see that we are publishing 2 times per second, or in other words, every half second. And that actually matches what we had over here in our code. Our timer period, remember, was 0.5 seconds. We're publishing a message every 0.5 seconds. So that's what we would expect, is a frequency of 2. 2 times a second we are publishing, 2 hertz. Control C. Now, what type of data is being published to this topic, and how many nodes are publishing to this topic? Let's do ROS2 topic info to find out more information about this topic. There we go. So here, when we did ROS2 topic info and then the topic name, we have the type of message that's coming across that topic, how many publishers, nodes, are publishing to that topic, and then how many subscribers are subscribing to data from that topic. If we want more detail, we add -- verbose to get more detail. And here you've got more detail than you could ever want. How many publishers, message type, node name, namespace, if applicable, topic type. All right, hash, a whole bunch of other stuff, quality of service, which you don't need to worry about now. So you can see a list of all of the topic commands by going, I'll just show you here. Let's go to Google. So let's go to understanding ROS2 topics, rolling. Okay, click on this. And here you've got all of the different commands on this website right here, which is the ROS2 website. All the different commands you can use to find out more information about topics. You already know ROS2 topic list, echo, and hertz, but you got many, many others as well. You can have a look at that later. Okay, clear. Okay, so let's move on to nodes. What are the currently active nodes? We've got our publisher running over here, a Python publisher, which is publishing a string message 2 times a second. and what are our currently active nodes. And to do that, we do ROS2 node list. We've only got one, which is Minimal Pi Publisher. Okay, Minimal Pi Publisher, same name. This is the node right here, Minimal Pi Publisher, right there. All right, and let's find some information about it. And to do that, we do ROS2 node info, and then Minimal Pi Publisher, enter. We got more information than we ever need right here. All right, published right here. Topic, all that other gobbledygook. Let's clear. And let's check out how all the nodes are communicating using this command, rqt graph. Let's expand it out. Okay, and let's click the refresh button in the upper left, and you can see we just have one node that's just publishing. So it's a very simple node graph because there's only one node that's publishing. Remember to click that refresh button in the upper left. That shows you the nodes. We got a lot of stuff going on. You can see the whole node architecture when you do the RQT graph, but only one node. So that's all we got going right there. So to close the node, you press Control-C. And now clear. Congratulations, my friend. You have written your first publisher in ROS2. So in this example, you've written a publisher to publish a basic string message, hello world. It's not the most exciting, to be honest, but it's similar to the kind of nodes you'll write again and again over the course of your robotics career. So how does this relate to a real robot? On a real robot, you will write many different publishers that publish data that gets shared by the different components of a robot. Strings, LiDAR scan readings, ultrasonic sensor readings, camera frames, 3D point cloud data, integers, float values, battery voltage readings, odometry data, and much, much more. So the code you wrote in this tutorial serves as a template for creating these more complex publishers. So don't sleep on it. All publishers in ROS2 are based on the same basic framework as the node you just wrote, pi minimal publisher.pi. And later on these tutorials, we're going to get to more exciting nodes. But these are the fundamentals. They're all based on this fundamental architecture for how to write a node. You just wrote a Python publisher node. That's it for this tutorial, and keep building.